Thanks for joining me and gathering around the telescope. I haven't said that for a while. Just wanted to get it out there. Anyway, we're going to talk about Io today. The moon Io, one of the Galilean moons around Jupiter. And are we missing something with it? The latest data, and let's go ahead and zoom in here. You can see Jupiter with the 4 Galilean moons around it. Let's kind of zoom in on Io. Here we go. Okay. The latest data coming in from Juno's Jupiter Infrared Auroral Mapper, or JIRAM, suggests that we have really been underestimating the thermal output of Jupiter's moon Io here. We've known for a long time that Io is the most volcanically active body in our solar system. There's a new paper that indicates that its volcanic depressions, or paterae, are pushing out way more energy than we previously have thought or been recorded. Most of our historical data relied on M-band infrared wavelength data. While great at spotting high temperatures, the peripheral rings, which can hit 900 Kelvin, the M-band is essentially blind to the larger, cooler central cluster of these lava lakes. Okay, so let's come in a little bit more here on Io and see if we can't you can begin to see some of these lava lakes that show up. The peripheral rings are blazing hot but small in surface area. The central crusts are much cooler. They're 220 to 230 Kelvin, acting as an insulating lid as they cover a massive area, as you can see here. Because these crusts are so much larger, their total thermal contribution is enormous. For example, the paterae known as P63 was previously estimated at about 7 to 20 gigawatts. With the new JIRAM data, that estimate has jumped to a staggering 80 gigawatts. So the study has also used thermal cooling models to estimate the resurfacing age of these lava lake crusts, and the math is really kind of suggesting they should refresh roughly every 8 to 10 years. This creates kind of a bit of a mystery, though, because when we look at Voyager images and data from 1979, the Galileo data from the 1990s, and then Juno today, the morphology of these lakes really hasn't changed much. So if the surface truly is renewing itself every decade, why does it look so consistent over 40 years of images and data that we're gathering from it? So what's next? There's still plenty of variables to account for. JIRAM can't map the entire area of the crust alone, and not all of Io's 400 plus paterae are structured like these lava lakes. Fortunately, Juno's going to be there for a little bit, and the mission's ongoing, and we can expect more high-resolution data to help us to understand these power estimates and solve the mystery of Io's static appearance. So what do you think? What do you think is going on the surface? Does the lack of visible change suggest our cooling models are off? Or is Io just remarkably consistent in its chaos? Let me know your thoughts in the comments. The link to the paper, head over to Eadsy Astronomy. Thanks for joining me, and we will catch you next time. Clear skies, keep looking up.